Hi guys, in this video we're going to look at how you can solve trigonometric equations algebraically. So you guys have last lesson been solving these using a calculator. So if you remember, we have done stuff like 5 cos x minus 4 equals 0, which you would have rearranged to cos x equals 4/5. And then you would have used a calculator to solve that. What we're going to do today is we're just going to look at cases where you can solve these algebraically, so no calculator. Now obviously that's only going to work in certain cases, because like if you tried to do this one here algebraically, you wouldn't really be able to do it because we don't really know what angle will give us a cosine of 4/5. We don't know that off the top of our head. But if you did have one of those values that you know from your unit circle, then we would be able to do it algebraically. So I'll give you an example of that. Let's say we had 2 sine x minus 1 equals 0. So kind of a bit of a similar thing to that first one that I was talking about. If we rearrange that, so we move the 1 over and then divide by 2, we would get sine of x equals 1/2. Now, if you have a look at your unit circle, we actually know something in this case, all right? This is something that we can solve. We know when the sine is equal to 1/2. We don't know when cosine's 4/5, but we do know this one. Sorry, and I should have added a little bit more information there. We're going to say that x is greater than or equal to 0 and less than or equal to 2 pi. So it's somewhere on the unit circle. So what we're going to have to do is we're going to have to sketch the unit circle just like we've done previously, because these are really hard to get our head around without a diagram. So if you're not sketching it and you're getting the answers wrong, you know what to do. You need to be sketching it. So let's have a look at what this means. Well, if sine of x is 1/2, that means that we're talking about here, because we know that when that angle there is, make sure I get this right, yep, pi on 6. We know that when it's pi on 6, the coordinates are √3 over 2.5, and the sine is the y coordinate. So we know that one solution is pi over 6, but as always there's a possible second solution as well, because we're talking about the sine, we're talking about the y coordinate. So there's another solution over here. It's a mirror image, so this angle in here is also pi on 6, but in terms of the unit circle we need to measure this angle all the way around here, and that's actually going to be 5 pi over 6. So that's our two solutions. So just to recap the steps that we've followed, first of all, we've actually, over here, we've rearranged it so that it's got the trig equation on one side, or sorry, the trig function on one side of the equation, and a number on the other. Now, because this number is one that we know how to do the inverse sine of, because we know that sine of certain angles gives us 1/2, from our unit circle, what we've done then is we've been able to draw a diagram and figure out what those angles actually are. Okay, I want to do another example, so I'll just bring that down a bit to give us some room. Let's do a tan. Now, I am actually taking these examples from the book. If you need to refer to their working out as well, if you don't like the way that I've done it. So let's say tan of x plus √3 equals 0. Well, that can be rearranged to tan of x equals negative √3. And again, we're going to say that x is somewhere between 0 and 2 pi. So we've rearranged it so that we've got the trig equation on the left and a number on the right. And square root of 3 is one of the tans that we know about, and if you refer back to your unit circle, I'm going to draw this one a bit bigger. if you refer back to your unit circle, that will actually be this point here, which has an angle of 2 pi on 3. And the reason for that is that that coordinate there is going to be, cosine is going to be negative 1/2, and the sine is going to be √3/2. Tan is the sine over the cosine, so it's the √3 divided by the 1. The over 2's cancel out. So we get negative √3. So that's how you can sort of mentally check it, or just refer back to your table, and you'll find that it's 2 pi on 3. Now that tells us one answer, so therefore x equals 2 pi divided by 3. But as always, there's a second answer too. And in the case of tan, you might remember that because tan is the slope, the other possible solution lies on a line with the same slope. So we just draw it straight through the middle and out the other side. So this other solution here, that's going to be basically another pi radians around, and that's actually going to come out to 5 pi over 3. So that's our other solution, 5 pi over 3. So remember, when you're solving tan equations, the two possible solutions are directly opposite each other. Okay, let's do another example, and we're going to ratchet up the difficulty a little bit here. Okay, I'm going to throw us a curveball. We've done a sine and a cosine. Let's do a, we've done a sine and a tangent. Let's do a cosine, but I'm going to make it cosine of 2x equals 1 on √2. And again, x is between 0 and 2 pi. So this is a little bit harder. So first of all, we don't actually need to rearrange this because we've already started with a trig equation on the left and a number on the right. So let's go straight to our little unit circle and think about what this means. All right, so the cosine of an angle, which happens to be 2x, not x, but let's worry about that in a moment. The cosine of an angle is 1 on √2. Now, in this case, that's actually going to be pi on 4. That's one of the cosines that we know about. And because it's cosine, we're talking about the x-coordinate. So the other possible solution is down here at 7 pi on 4. Now, here's the tricky bit to get your head around. Because we're actually solving for x and not 2x, we need to think about the values that 2x could take. So up here we've got x. Underneath, I'm going to change that to 2x. Now, because it's a 2x, I've multiplied by 2. So I need to multiply the other two values by 2. So the 0 is just going to stay as 0. And the 2 pi is going to become 4 pi. So now the angles that we're talking about could be anywhere between 0 and 4 pi. 4 pi is actually 2 full laps of the unit circle. So now we have some more possible solutions. So let's just start a list over here. So 2x, which is what we've taken the cosine of, could be pi on 4. It could be 7 pi on 4. That's the two that we've already drawn. Or we could actually do an entire lap of the unit circle and then come up to pi on 4 again. So that's going to be a total of 9 pi on 4. So 8, remember 2 pi is 1 lap. So that's like 8 pi on 4. And then we've added another pi on 4 to get 9 pi on 4. And then we could keep going around and around and around and around and around all the way back to here. So now we've done a lap of the unit circle, and then we've gone all the way around by another 7 pi on 4. And we are going to end up at 15 pi over 4. The reason for that just to restate it, is that our range for 2x is all the way up to 4 pi. And if we're talking about multiples of pi on 4, 4 pi is equal to 16 pi over 4. So 15 pi on 4 is still within that range. Okay, so we're trying to think of all the possible solutions. So in this case, these 4 are all of the solutions that we can get, because we can go 2 full laps of the circle, so there's double the amount of solutions. And they're all the possible values of 2x. So the final step is to actually figure out what x can be. What I'm going to do is I'm going to divide, if I'm going from 2x to x, I've got to divide both sides by 2. And if I divide any of these fractions by 2, I'm just going to change the bottom line to an 8. So I'm going to get pi on 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8. So just to recap, I've done exactly the same thing as earlier, but because I've got a 2x, I had to change the range of the possible values, and that meant that I had to consider going 2 laps of the unit circle instead of just 1. That gave me 4 possible solutions, and then I had to divide this 2 onto both sides of that equation to basically give me my full set of solutions here. Okay. I'm going to do one more example which is a little bit similar. So a final example. This is also in the book. What I'm going to say is that sine of x divided by 2, let's make it 2 sine of x divided by 2 equals root 3. First thing I'm going to do is what I did earlier, and I'm going to rearrange it so that the trig function is actually by itself on the left. So I'm just going to divide both sides by 2. Oh, and as usual, x is somewhere between 0 and 2 pi. But now I've sort of in a bit of a different scenario because I've got x over 2. So I need to do the same thing. I need to go over here and look at my range, and I need to think about x over 2. So if x is between 0 and 2 pi, x over 2, well, I'm going to have to divide it all by 2. So 0 divided by 2, well, that's 0. 2 pi divided by 2 is pi. So now I've changed my range to 0 to pi. Well, that almost makes things easier, doesn't it? Let's draw the unit circle. A little bit little. That's okay, we can deal with that. In this case, the sine is equal to root 3 over 2. And if you go to your unit circle, that will be the case for an angle of pi over 3, because the coordinates there are a half root 3 over 2. The other possible position on the unit circle, because we're talking about the y coordinate, is up here at an angle of 2 pi over 3. So let's just think about our range here. We've said that the angle that we're interested in, which is x over 2, is between 0 and pi. Well, both of these solutions that we've found are between 0 and pi, so that's fine. We're going to take both of them. It is possible maybe that you could get a solution outside of that range, in which case you'd ignore it. But these two are between 0 and pi, so our possible solutions are x over 2 equals pi on 3, or 2 pi on 3. And then to finish this off, what I've got to do is I've got to multiply both sides of the equation by 2 so that we've just got x on its own. So I'm going to multiply the 2 up to the other side. So that's going to become, pi on 3 will become 2 pi on 3, and 2 pi on 3 becomes 4 pi on 3, and that's my answers. So again, same thing. I've rearranged the equation to get the trig function all by itself on the left. I've adjusted the domain of the function. I've adjusted what I'm doing here with to x over 2 because x over 2 is the angle that we're interested in. I've then looked for my possible solutions in terms of x over 2, and then I've just had to multiply by 2 on both sides to get the actual values for x. Okay, I hope that makes sense. I'll set you some questions from the book to follow up with this. Thanks for watching.